If you know what the substitution is, keep it to yourself. Give yourself an opportunity to think about it, Daniel. You picked kind of a not real clean one, but it works. Bless you. Bless you. Let it go. Blow your eardrums out.
I want to say u is square root of x minus 1.
Okay. Any particular reason why you think it's square root of x minus 1? That just feel good, or you going?
The derivative of square root of x is 1 over 2 times square root of x, which you already have that if you take off the numerator and put it on the side.
All right. Let's see. Everyone see this? If you choose this, right, you already know the derivative of this is this, right? So you need to see this somewhere, and you're saying you see it. Because this root x really can be, you said, pushed off to the side, right? So let me rewrite that as, well, if I'm going to move this denominator over, then it's going to be root x minus 1, that quantity squared, and then what would you have over here, Daniel? What do you want me to write here?
1 over square root of x.
1 over square root of x, and then I'd have dx. That's the same expression, isn't it? And do you see the 1 over root x here? And the 1 over root x here, everyone? Now we're off a little, aren't we? The 2 is a problem. But we should be okay if we're off by a constant. So very good, that's perfect. So this is why in the beginning of class I said, what will make Cal 2 easier for you is if you're comfortable with derivatives. If you're already comfortable with them, you can see them already, then this stuff becomes a lot easier to do, right? But if you don't know what the derivative of this looks like, you're never going to see it in there, are you? All right, so next thing, we're good, okay? Anyone can respond now. You're off the hook. Thank you. All right, so now what I do is I always clear out the dx on both sides, like that. And probably on the next example, maybe the one after that, I'll stop doing this step, and I'll just go straight to this step. So instead of writing du dx and this, I'll write du, and then I'll take the derivative, and I'll just slap a dx on the end of it, just to save myself one step. All right, now play a little matching game, right? So you want this right here. Yeah, everything in terms of u. This right here is going to be u, right? And then I'm trying to get this 1 over, did I just do that? I did that, didn't I? Just going to use blue again. This right here, I'd like to have that over here. But that 2 is a problem, so how are we going to resolve that? Multiply both sides by 2, right? We multiply both sides by 2, we'll get 2 du equals, it clears this out, you just get 1 over root x dx. And now it matches, doesn't it? This right here matches exactly this. So what am I going to replace that 1 over root x dx with? 2 du. And that'll be multiplication between those. So I'm ready to rewrite the integral. And when I rewrite this, I will have u squared, right, 2 du. The 2 I'm going to bring out right away. Just bring it out of the integral. I'll have my u squared and then du. And for that, it's just a power rule, right? You're looking at the u squared in there. You're saying, what's the antiderivative of u squared? 1/3 u cubed, right? So no more integral sign, because I'm actually taking the antiderivative now. 1/3 u cubed plus some constant. Y'all with me or not? Anyone have a question? Need me to clarify something? So what's my final answer then?
2/3.
2/3. Write that as one fraction. Parentheses. Square root of x minus 1. That's your u, right? That was u right there. Cubed plus c. Box it up and you're done. Good job. Now, can I get an honest response? Let's see if I can get an honest response. How many of you saw that substitution? Yeah? Okay. I mean, before Daniel said it, yeah? Okay. All right, where's my next volunteer? All right, let's just go, we'll just move this way across. So, what was your name again?
Roland.
Roland. All right, Roland. Here it comes. Let me get the advanced sheet out real quick. No, I'm kidding. No. 1 through 28 with the exception of, what did we just do, 8? Okay. 4. They like to use T here a lot in this worksheet. Wait a minute, hold on. Didn't I just do this one? I just did that one, I'm sorry. I did number 4 on here. You can't do 4. Sorry, something else. It's like, that looks familiar. 8's already been used. 14. All right, that's not so bad. All right, Roland is the one who is playing right now. X to the third plus 1. That's it. Is this one too obvious? Yeah, this one's too, I think this one might be a little too obvious. Derivative of that's just 3x squared. You've got x squared sitting out front. What if this was an x out here instead of x squared? This wouldn't work, okay? So it's very important that the problem that we're presented with fits the mold. If it doesn't fit this mold, we're going to have a different way of doing it, which we will, but we're just not there yet. So now I'm going to write du. I'm going to take the derivative, 3x squared dx. See how I did that this time? And now I'm going to play my game. I'm going to play it a little different, though. I'm just in the way I write things. This right here is going to be replaced with what? U. And then, instead of having to rewrite the whole thing, just remember, this clumped along with this, those two together, right, are going to become something? What are they going to become? 1/3 du, because you have still got to scale this to get x squared dx, right? You need x squared dx, so you need that 3 out of here, and you scale it out. All right, Roland, do you want to tell me what that rewritten integral is going to look like?
1/3 integral square root of u x squared dx.
Not x squared dx. X squared dx got replaced. You shouldn't have using x's. Du, right? And then 1/3 came out. There we go. And to save us a little time, I'm going to assume you can take the antiderivative of that. You should get, at the end of this, when you take the antiderivative, anyone know what the number is out here? 2/3. U to the 3/2 plus c. So you just turn that into u to the 1/2. N is 1/2. You do your thing. You get this. And so we should be at 2/9 u, which is x cubed plus 1, and then to the 3/2 plus c. Any questions there? Y'all have got it. Let's go home. Let's start the weekend. All right, where's my next volunteer? Think here? Okay, what was your name again, sir?
Chase.
Chase. All right, Chase. Go ahead. Pick a problem.
20.
20. Oh, this one's interesting. This is a good problem. Good choice. This is almost fun. Almost. Okay, so you're thinking x cubed because why?
Because when you get the derivative of that, it's 3x squared, and we're off by a constant, which is okay, and then we can just increment for it.
Okay, I'm with you. I see what you see. But what was it about the derivative? Like you see the something and its derivative. What were the things about the derivative, some conditions we had to have?
They ended up having the same power. Once you take the derivative of x cubed, it matches.
It
x
does
squared.
match this.
Yeah, and then
Let me go back to this.
when we end up taking the derivative of x squared plus 1, the 1 goes away, where you're left with only x.
Well, hold on. I'm trying to help you see this, okay? I think you said let u be x cubed because the derivative of this would be 3x squared, and then I'll tack that dx here, right? That's kind of what you're seeing? And so you're off a little bit because you don't have 3x squared, but you have x squared. But here's the something, right? Here's the derivative of that something. The derivative should appear in the numerator, which it does, but I said not only numerator, and I should edit my notes. It can't be trapped, okay? That's the main idea on that point, that number 3. Let's go ahead and just edit that now. Should be in numerator / not trapped. And the reason why it can't be trapped is what have we been doing with that? Once we replace it, right? Haven't we been sliding everything to the back and then like rewriting it? You can't slide x squared out of that root. You see that?
Make x squared minus 1 be.
Okay, so now we're still letting Chase think through this, okay? Does everybody see why this is a problem? That you can't do it? You sure? Okay. So your next instinct here was x squared minus 1? Okay. So I'm going to go with x squared minus 1 as the substitution. Then the derivative of this would be what?
2x.
2x dx. Do you see this somewhere not trapped, Chase?
I do not.
You do not. Yeah, and I don't see it clearly, but it's there. Yes?
Should you like separate the x in front, like instead of like write 3x's or something, and you have the x?
Oh, okay, so you're saying, oh, this is your u, right? This is not the x we need, right? But you're saying it's x times x times x.
Yeah.
Yes? So let me just go with that for a second. You all following that? That's a suggestion? I'm going to say maybe. Let's see what we do with this, all right? That means I would need to replace, if I replace things, I can replace x dx, right? With something with the u. I'd probably have to scale out that 2, right? That 2 is a problem. You'll see that? The best I could do is replace x dx. And I can replace x dx with 1/2 du. So if I look back over here, I could replace x dx. That's taken care of, right? The square, sorry, not the square root, the x squared plus 1, that's taken care of. But we still have 2 x's out there, don't we? And you cannot solve this for x, because if you do solve this for x, you bring that dx back over there, you're going to have x's and u's mixed up. Look, this expression will have x's and u's, won't it? Okay. What was your name? Okay, you're right. And I don't want anyone else saying anything. Do you see what you need to do? There's something else. You're right there. Everything in blue is taken care of. What do you have sitting out in front that's causing you problems? Alexa? What's causing you problems out there?
Those extra
How many do you have?
Could you do like, see, because if you combine them and then the derivative of x squared is 2x, and then you have another 2, but does that help?
You said combine these, right? X squared. The problem is x squared, you don't want x's, you want u's. So Alexa, do you see anywhere over there where you have a connection between u's and x's that you could use here? Okay? Solve it for x squared. What do you have? U plus 1. So do you all see that? If I take this equation and I solve it for x squared, what would I get? U plus 1? Just moving one to both, or adding 1 to both sides. So when we come in here and we say u is x squared minus 1, and do all this work, that equation is legitimate. And in our entire problem, we can use this equation any way we need it. And it just so turns out that we could cover everything in the integrand except an x squared. And lucky for us, this equation can be solved for x squared. And because of that, I can replace that front piece with u minus 1, or u plus 1. Yes?
Instead of doing that, could you just make your u x squared? Like, would it be okay to have that minus 1 under the square root?
Well, what would happen is if you did that, the question is, could we have just used x squared? Everything would have been fine here, right? We still would have had that and that covered. This would not all be covered. It would only be this, right? And then this right here would just be u, wouldn't it? Right? Yes, but the problem is what you'd have left, you would have this. 1/2. We'd still have that. You'd still have u minus 1 du. That's where you would be. Do you see that? Because of the minus 1? And at this point, you would kind of be stuck again because you can't pass the u through. So that would be grabbing the right thing, but not quite enough. Now let's see why this is still going to work, though. All right, what we've got here is going to work. Are y'all ready to rewrite it? Okay. I'm going to rewrite this. Let's do it piece by piece, and if I have any constants, I'll pull them out at the end. X squared is being replaced with u plus 1. I'm going to put it in parentheses because it's 2 terms. U plus 1. All right. How about this x and this dx? What's that being replaced with? 1/2 du. I'm going to slap it to the back, all right? And then what's this root x squared minus 1 being replaced with? Root what? Root u. Just u, right? Root u. Does everybody see where everything came from there? No questions? All right.
And then we bring our constant out.
Yeah, let's go ahead and bring that constant out. 1/2 came out, integral. I have u plus 1. I have a root u there, don't I? Okay. I'm leaving it blank for a reason. What are you going to do with this root u? Multiply it into the parentheses, right? So remember that root u is really u to the 1/2, isn't it? And I can pass that through this parentheses. The reason I can do it is because this parentheses is to the first power. So do you see how, Laura, right? Did you see how what you suggested just a second ago, we would have been like this? I think it was that. That we couldn't really quite do what we would want to do here. Like we would want to maybe try and pass this through, but we can't because order of operations. But this expression we can. And so it's going to be doable at this point. And these are little subtle things. You see, you're going to have to try some substitutions. Some of them are going to work, hopefully right away. And some others, you're just going to have to play with it. All right, so let's go ahead and pass this through. This is 1/2 integral u to the 3/2 plus u to the 1/2. Why am I passing that through? I didn't even bother talking about that. Why am I passing that through? Because now I can do these one by one, right? I've just split it up. I can split it up into 2 different power rule, I'm done. All right. Let's make sure we get this now. I have a 1/2 out here. Now, what is the antiderivative of this? 2/5 u to the 5/2. 2/5 u to the 5/2 plus antiderivative of this one. 2/3 u to the 3/2. Now, why do you think I put that in brackets?
Because the 1/2 has
The 1/2 has to get applied to both of these, right? Not just the first one. So I put it in brackets. You could have used parentheses, but I did brackets just to kind of like reinforce that it needs to be separated. Distribute the 1/2 through, replace u, and we're done. So when we distribute a 1/2 through, we get 1/5 u, which was, wasn't it x squared? Was it -1? -1 to the 5/2.